For question number 3 in section 5.6, we're asked to graph the inequality on a plane. The inequality only has an x in it. X is less than -4. So this inequality is a vertical line that only goes through -4 on the x-axis. So it only has an x in it, so the line is going to be a vertical line, and it's going to be a dotted vertical line because we're using the less than. So I'm going to draw a dotted vertical line through -4 on the x-axis, and then we need to determine which region to shade. Because it is a less than sign, we are going to shade to the left. The solution to this inequality are all the x values that are less than -4. The x values that are less than -4 are all the x values to the left of -4. So every single point in this region would be a solution to the inequality. The way we graph this on the homework is to select the line tool and graph a vertical line through -4. I plot one point on -4, and then I can plot another point anywhere that would make it a vertical line. Then I switch from the solid line to a dotted line by clicking on that little dotted line button. Now pick up the paintbrush and shade to the left. Save and check your answer to see how we graph the inequality x is less than -4. Whenever the inequality only has an x, then the inequality when you graph it is going to be a vertical line. Let's look at number 4. For this one, we want to graph the inequality y is greater than x minus 1 squared plus 2. Now, hopefully you should recognize that this is in the form of y equals a times x minus h quantity squared plus k. The only difference is that this is a greater than sign and this is an equal sign, and we talked about how we graph these parabolas in the previous chapters. So imagine you're graphing y equals x minus 1 quantity squared plus 2. This is a parabola that's been shifted to the right 1 and up 2. So you can pick out the coordinates of the vertex, the minus h and the plus k. You can recognize the vertex. So we can recognize the vertex of this parabola. It's been shifted to the right 1 and up 2. The vertex of this parabola is 1, 2. Now we do need to find one other point to graph the parabola. If the vertex is right here at 1, 2, let's choose a point close to that vertex. And I tend to choose a point that's pretty close to the vertex 1, 2. Let's say we want to determine the value if you plug in 0 for x. If you plug in x equals 0 into this x right here, we get the quantity -1 squared is 1 plus 2, you get 3. So that is going to be one other point on the graph. So we can graph the point 0, 3, and because there's symmetry, there's going to be another point over here. And this is a parabola that opens up. Now, we're going to use a dotted line. Oops. We're going to use a dotted line because the inequality is a greater than, and also it's in the form of y is greater than, so that means we're going to shade above. All the y's that are greater than, so we're going to shade above that parabola. I'm going to select to draw a dotted parabola, and we're going to do the shading above the parabola. So the solution to this inequality are all the points that are in that shaded region. To do this on our homework, we're going to select the parabola tool, plotting the vertex at 1, 2, and one other point. I'll choose 0, 3. Change the solid line to a dotted line. Pick up the paint bucket and fill in above the parabola. Save and check your answer to see the graph of the inequality. Let's look at number 5. For question number 5, we're asked to graph the inequality y is greater than 2 to the x plus 1. Now this is an exponential function, and recall we had exponential growth or exponential decay functions. This is a graph of y equals 2 to the x that's been shifted up 1 unit. So let's look at, we can even make a table of values to graph y equals 2 to the x plus 1, just using a couple values for x and y. If I plug in, say, -1, 0, and 1, plug in -1 for x, we get 2 to the -1 power, which is a half, plus 1, we get 1.5. Plug in 0, 2 to the 0 power is 1, 1 plus 1 is 2. Plug in 1 for x, 2 to the first power is 2, plus 1 is 3. So this just gives us a few points to start off with. When x is -1, 1.5, when x is 0, 2, 1, 3. This is an exponential growth equation, and since it is a greater than sign here, because we have greater than, that means we're going to use a dotted line, and we're also going to shade above that line. Not a line, sorry, curve. So we have the graph using a dotted exponential growth equation, and then we're going to do the shading above. So the solution to the system of inequalities are all the points in that shaded region. If you plug them in to the original inequality would be true. Out of all the choices, for mine it looks most like choice A. I'm going to check my answer. All right, continuing on, let's look at question number 6. Graph the solution set of the system of inequalities. We have two different inequalities. Now in this case, we want to actually find where the shading would overlap those regions. So let's break this into two different parts. The first inequality is x plus y is greater than or equal to 0. Solve this for y so we can get it into the form of y equals mx plus b. We want to graph these lines. I'm going to subtract x from both sides, and then that will give me y is greater than or equal to negative x. In this case, the slope of the line is -1/1, and the y-intercept, b, is equal to 0. So I'm going to plot a line where the slope, the y-intercept is 0, starting right here at the origin, and then I'm going to go down 1 to the right 1, down 1 to the right 1, and so on. Or you can go in the opposite direction. And I'm going to draw a solid line through those. Now for this one, since it is greater than or equal to, I would do the shading above. Now when I work it out by hand here, that's my strategy, but when I actually write the final answer, I'm only concerned about where that shading overlaps. Now the second equation, I want to graph that as well. That was x minus y is greater than or equal to 2. Solve for y. I'm going to subtract x from both sides, and I get negative y is greater than or equal to negative x plus 2. I want to get y by itself, so I'm going to divide everything, both sides, by -1. When you divide an inequality by a negative, the direction of the inequality changes. So my simplified answer is going to be y. That greater than or equal to turns into a less than or equal to. Negative x divided by -1 is positive x. Positive 2 divided by -1 is -2. So this is a line. The slope of this line is 1/1, and the y-intercept is -2. So I'm going to plot here. Oops, sorry. Let's go back. plot the y-intercept of -2 and use a slope of up 1 over 1, up 1 over 1, and so on. This is also going to be a solid line. And since this is y is less than or equal to, I'm going to shade, using a different color here, everything below that line. Now when I graph this on the homework, I only want to shade the part where the shading overlaps. So I will only end up graphing shading this part of the region. I wouldn't sketch those. So let's look at how we can graph this solution. I'm going to pick up the line tool. The intercept is 0 for the first one and the slope is -1. That line, I don't do the shading until the very end. Pick up the line tool again and I graph a line that has a y-intercept of -2 and a slope of 1. So now you see those two lines break up the region into 4 parts. When we do the shading with the paint bucket, we only shade the part where the shading overlaps. And in this case, it's only this section, the part that overlaps. You can save and check your answer. All right, so be careful when you do these, only looking at the part that overlaps. If you're using pencil and paper by hand, use highlighters. You could highlight one of these with yellow and the other one with blue, and the part where the overlap is going to be green, and that's the only part that you would fill in with the paint bucket on the homework.